Hi everyone, it's week 14. It's Instructor John here, and we're going to do some Chapter 10 problems. Now, Chapter 10 covers a lot of ground, and I'm feeling a little bit guilty about that, but it's a lot of work for 1 week, but hey, you're used to it, and I'm over it, so let's get on with it. The first problem I'm going to do is in section 10.1, so it's kind of the introductory problem. And what we're doing in all these sections is really pretty much what we've done all the last couple of weeks. We've created a sample. So first of all, we set a set of hypotheses, things we want to prove to be either true or false as best we can given the uncertain nature of statistics. But what we do is we set the hypotheses, the null and the alternative. We take a sample from the population and we calculate a test statistic. And then we compare that test statistic against an alpha value, a level of certainty that we want to have in our conclusion. And if the test statistic is greater than the critical value, we say, you know, the null hypothesis just can't be believed. This sample we drew just is too unlikely that we would get this result if we drew a sample from the population with the hypothesized, the null hypothesis assumption. So it can't be right, and that leaves us with the alternative assumption. Now we're going to do exactly that in this chapter, only the difference is we're going to use 2 samples instead of 1. You can think of it as a before and after sample. So let's try it in problem 10.6 found on page 394. We're being asked to perform a hypothesis test on 2 means, mu1 and mu2, drawn from the 2 samples you see here. This first sample had 7 units and came up with an average of 240 and a sample standard deviation of 5. Now we did repeat with another 7 samples. This is the after case. And we came up with an average of 210 and a standard deviation of 6. Now the question is the difference between those 2 samples, can we be confident that the difference in the 2 population means is 20? Or is it not? And if it's not 20, then of course it could be either greater than or less than, but we just want to know if the difference is 20 or not. Well, take a look at the textbook. First of all, at the top of page 391, you see a t-test about the difference between 2 population means with equal variances assumed. Now this is kind of a fudge deal. We're assuming equal variances, which allows us to make the formulas a little bit simpler. If you flip the page over to 392, you can see that we get some pretty hairy looking formulas here, especially for the degrees of freedom. But I won't try to do that in this video. Let's try the simplified version where, yeah, you know, our means our standard deviations, our variances that is, are pretty close, 25 and 36. The book says as long as they're not off by more than 3 to 1, you're okay to use this formula, and we're very close here, so let's use it. Now, the test statistic formula is shown here, and it looks pretty good, doesn't it? But except, wait a minute, in the denominator it's got this SP squared thing, and we've got to calculate SP squared, and that came from the previous page on page 389, where we get a formula like the one you see here. SP squared is the n1 minus 1, that is the degrees of freedom of the first sample times the variance of the first sample, plus the degrees of freedom for the second sample times the second sample's variance, divided by the degrees of freedom for the whole mess, n1 plus n2 minus 2. Once we get that little baby calculated, we can go ahead and calculate the t statistic, which is the difference between the 2 sample means. Take off the D0, the difference that we're interested in. A lot of problems we'll do this week, and homework, by the way, says D0 to 0, but they'll just for fun put in 20. It's just sort of a bias, an offset. And then you divide that by SP squared plus times 1 over N1. Am I missing a parentheses there? Looks like I am. Let's try that again. Yeah, we've got to have, I'll try to put I'll put another parentheses in like that. And keeping parentheses straight, as you've learned in Excel, is really important. I know what I meant to say there, but Excel doesn't. Okay, let's plug in some numbers. I'm not going to plug them in. I've already done the arithmetic. So n1 minus 1 is 6. S1 squared is 5 squared is 25. We add to that n2 is n minus 1. n2 minus 1 is 6 times 6 squared is 36. Divide the whole mess by 7 plus 7 is 14 minus 12 is 2, right? And what do we get? We get 30.5. There's the formula up here in the formula bar if you're interested. Okay, we've got that number. Now let's see what we do. First of all, we need the numerator. And that's pretty straightforward. It's the difference between the two means, which would be 240 minus 210 is 30. And subtract from that d0, which is 20, so that gives us 10. That makes sense. I got that one right. And here's the denominator. 2.95197. Okay, what is that? Well, it's the square root of d31, which is sp squared, and multiplied by 1 over b21 plus 1 over d21. That's n1 and n2. Okay, so we're good to go there. We turn the crank, and what do we get? We get a test statistic, which is 3.38. If you look at the back of the book, it'll tell you that for 10.5, it'll tell you the test statistic is really 3.39, but hey, we'll be a little more precise here. Now what we need to do is compare that with the table in the back of the book for the t-table. Well, I've just created a little piece of the back of the book table here, so we don't have to do the page flipping. And here it is. Now what I've done is I've shown the different probabilities and its range of degrees of freedom, 12, 13, 14, 15. Now this is telling us that our test statistic needs to be n1 plus n2 minus 2 degrees of freedom. So 7 plus 7 is 14 minus 2. That's 12 again. So this is the line in the table we're interested in. Now, it tells us to test this against a variety of probabilities, 0.1, 0.05, 0.01, and 0.001. So tempting, isn't it, to say, well, 0.01, wait a minute, this is a not equal to problem. So we have to move down a notch and say we have to compare against 1.792 when we're doing the alpha of 0.01. So is 3.38 greater than 1.782? Yes, rejected. How about 0.05? Well, again, we have to move over one because we're now testing half of the alpha. So, but again, 3.39 is greater than, so we can reject H0. What was the next one? 0.01. Well, again, we have to use the next one over. 3.38 is still a little bit greater, so we can reject H0. But when we get to 0.001, and especially the alpha over 2 value, we see we have to reject. We cannot reject H0, and must assume that it is true. So we have very strong evidence, not extremely strong, but very strong evidence. And again, you want to flip to page 356 if you want to confirm that. Okay, that's all there is to this. Just a little bit more arithmetic, but the process is exactly the same. All right, let's move on to video B, and we'll do yet another problem.